Hello again and welcome back. Tonight, we're going to slow down and travel somewhere very far away. Not across an ocean or over a mountain range, but back through time itself. Back to a world so different from our own that it would be almost impossible to recognize. A world where the map you know, the one with its familiar shapes and borders, its blue oceans and green landmasses, simply did not exist. Before we begin, let yourself settle. Whatever you're lying on, feel its weight supporting you. Let your shoulders drop. Let your breathing slow. Because this story moves at the pace of the earth itself, which is to say, very, very slowly. There is no rush here. There is no deadline. Only time unfolding in all directions. The world map we carry in our heads feels permanent. South America fits neatly into the Atlantic. Africa anchors the center. Europe rests at the top like a crown, and the great spread of Asia stretches east toward the quiet rim of the Pacific. It feels as though it has always been this way, as though the continents were placed by some steady, deliberate hand and told to stay. But they weren't. They never were. The continents have been moving for as long as the Earth has existed, drifting, colliding, tearing apart, and coming together again in a slow, patient dance that has been going on for 4 billion years. The map we know is not a destination. It is a snapshot, a single frame in a film so long that no human mind can hold it all at once. Tonight, we are going to try. We'll start at the very beginning, when the Earth itself was new. We'll watch the first continents rise from a molten world. We'll follow them as they drift, break apart, and crash into one another. We'll see oceans appear and disappear. We'll watch mountain ranges fold up from nothing and then wear back down to dust. And at every step, we'll try to understand what it all means, how the world got its shape, and how that shape made us. Let's begin. The story starts in fire. Not the fire of a candle or a campfire, not even the fire of a forest burning. This was the fire of a planet being born, a world still forming, pulled together from swirling clouds of gas and dust, left over from the birth of the sun. Roughly 4.5 billion years ago, the Earth was not a solid thing. It was a churning sphere of molten rock, bombarded constantly by asteroids and debris still tumbling through the early solar system. The surface glowed. The sky was thick with vapor. There were no oceans, no atmosphere as we know it, no land to speak of. Just heat and pressure and the slow grinding work of gravity. This period is called the Hadean Eon, named for Hades, the ancient underworld, and it earned its name. The surface temperatures were high enough to keep rock liquid. The atmosphere was a choking mix of carbon dioxide, methane, and water vapor. If you could have stood on the Earth then, which, of course, you could not, you would have seen nothing that resembled a world capable of life. And yet, even in that chaos, something was happening. Slowly, almost imperceptibly, the surface was beginning to cool. The heaviest materials, iron and nickel, were sinking toward the center, forming a dense metallic core. The lighter rocks were rising, collecting near the surface. The first crust was forming. Not stable yet, not permanent, more like a skin of cooled rock, constantly being broken and pulled back under by the churning heat below. But over millions of years, those first fragments of crust grew thicker, more resistant. Small patches of rock began to rise above the surrounding magma, like the first islands in a sea of fire. These were the cratons, the ancient cores of what would one day become the continents. They were not large. They were not impressive to look at. But they were old in a way nothing else on Earth can claim. Some of them still exist today, buried deep beneath the continents, unchanged for billions of years, silent witnesses to almost everything that has ever happened on this planet. Even as the surface cooled, the violence from above continued. The late heavy bombardment, a period roughly 4 billion years ago, saw a surge of asteroid impacts that pummeled the young Earth relentlessly. The moon, which had formed not long before from the debris of a massive collision, still bears the scars of that time in its craters and basins. Earth too was struck again and again, but Earth unlike the moon, has spent the years since hiding those scars, burying them under rock and water and life. The bombardment eventually slowed. The surface grew more stable, and something happened that changed everything. Water arrived. Where it came from is still debated. Some of it was already locked inside the rock of the planet, released as steam by volcanic activity. Some may have arrived on asteroids and comets, those icy travelers from the outer reaches of the solar system. However it came, it gathered, it condensed, and it fell as rain. Imagine that rain, not a gentle shower, but a deluge stretching across millions of years. Hot rain falling on hot rock, steam rising back up into a dark sky, only to condense and fall again. Slowly, the low places filled. The first oceans formed, not wide and blue as we imagine them, but shallow and dark, and filled with minerals leached from the cooling rock beneath. The earth now had its two great features, rock and water, land and sea, and between them, the long argument that has continued ever since, over which one would win. Time moves differently when you're thinking in billions of years. Each million years is like a single breath. Each 100 million years a single night's sleep. At this scale, the continents are not fixed things at all. They are travelers. Slow ones, but travelers nonetheless, moving an inch or two per year, which adds up over deep time to journeys of thousands of miles. By about 3 billion years ago, the cratons, those ancient cores of early crust, had begun to collide. When two pieces of continental rock meet, they don't simply stop. They buckle, they fold upward. The rock crumples like paper under the irresistible pressure of two continents pushing against each other. And where they collide, mountains rise. These first mountains are long gone, worn down over billions of years to gentle hills, or nothing at all. But they were real. And the collisions that built them were the first steps in the making of something larger. Scientists have given names to the supercontinents that formed and broke apart across the deep history of the Earth. The earliest ones are the least understood, their existence pieced together from ancient rocks and the magnetic signatures still locked inside them. But there is one that scientists are most confident about, one that formed roughly 1.1 billion years ago, and which we call Rodinia. Rodinia, from the Russian word for homeland. It was a supercontinent in the truest sense. Almost all of the world's landmass gathered into one, a single enormous body of rock surrounded by a single global ocean we call Mirovia. The world, from above, would have looked almost unrecognizable. No Atlantic, no Pacific as we know it, just one vast supercontinent and the endless ocean circling it. What was Rodinia like? It's hard to say with certainty. The land was almost certainly barren, no forests, no grasses, probably no land life at all, or very little. Microbial mats may have clung to wet rock near the coasts. The sea held simple life, single-celled organisms drifting in the warm, shallow water. But the land itself was lifeless, wind-scored rock, bare, red, and ancient. A landscape that would feel alien to anyone who has ever seen a forest or a field. Rodinia did not last. Nothing in geology does. The heat deep within the earth, that same restless churning that had been going on since the beginning, was still at work. Hot rock rising from the mantle pressed upward against the underside of the supercontinent, weakening it, stretching it, until it began to crack. The breakup of Rodinia happened over tens of millions of years, beginning roughly 750 million years ago. Rifts opened across its surface, narrow at first like the cracks in drying mud, then wider. The ocean rushed in. Where once there had been a single landmass, there were now fragments drifting away from each other across the face of the planet. And then something remarkable happened. The earth grew cold. When Rodinia broke apart, it exposed vast stretches of fresh rock to the atmosphere. That rock weathered quickly, pulling carbon dioxide out of the air in a chemical process called silicate weathering. As carbon dioxide levels dropped, the greenhouse effect weakened. The planet cooled, ice formed at the poles, and then in one of the most dramatic events in the history of this planet, the ice just kept going. The glaciers spread from the poles toward the equator. The oceans began to freeze at their surfaces. Ice sheets advanced across the continents, and eventually, roughly 700 million years ago, the entire Earth was covered in ice. Snowball Earth, that is what scientists call it. A planet from pole to pole, its surface white and still and silent, the ocean sealed beneath kilometers of ice, the sun's light reflecting back off the frozen surface, keeping the temperature low year after year after year. It is almost impossible to imagine life surviving, and yet it did. Hidden in the deep ocean near volcanic vents, where heat seeped up from below, simple organisms clung on, waiting, as they had always done. The escape from Snowball Earth came slowly, through the one force that couldn't be frozen: volcanoes. Erupting through the ice, or from the ocean floor, they pumped carbon dioxide back into the atmosphere over millions of years. With nowhere to go and no exposed rock to absorb it, the gas built up. The greenhouse effect strengthened, and one day the ice began to melt, slowly at first, then faster. Then, as dark ocean and rock were exposed, absorbing heat instead of reflecting it, the melt became a flood. The world thawed, the oceans opened, and life, which had been waiting in the dark, exploded outward into a warmer world. The thawing of Snowball Earth set the stage for something entirely new, not just in geology, but in life itself. The period that followed, the Ediacaran and then the Cambrian, saw an extraordinary burst of biological innovation. Life, which had been simple for 3 billion years, suddenly began experimenting. Bodies appeared, shells, eyes, movement. But we are here tonight for the continents, and while life was learning to walk, the earth beneath it was not standing still. The fragments of Rodinia were still drifting. Some were converging again. About 600 million years ago, a new supercontinent was forming in the southern reaches of the planet. We call it Gondwana, Gondwana. Say it slowly and it sounds ancient, because it is. Gondwana was not all the land on Earth. A smaller landmass called Laurussia existed in the north, but Gondwana was enormous. It contained what would one day become South America, Africa, Antarctica, Australia, India, and the Arabian Peninsula. All of them fused together, all of them one. For roughly 200 million years, Gondwana dominated the southern hemisphere. The world during this time was vastly different from what we know. The continents were low and flat in many places, flooded by shallow inland seas. Life had moved onto land. The first forests were growing. Insects the size of birds flew through the warm air of the Carboniferous. Amphibians crawled through swampy deltas. The world was green in a way it had never been before. And all of that life, all of those forests and swamps and warm coastal seas, was being carried slowly across the face of the planet by the motion of the crust beneath. Picture it, a forest of giant club mosses and tree ferns, their trunks as wide as a person's arm span, growing quietly in the tropics. And beneath them, invisible, unstoppable, the rock on which they stand is moving. A fraction of an inch each year, so slowly that no creature could feel it. And yet the direction of the whole continent was shifting, turning, drifting, carrying its cargo of life toward a new destiny. Those ancient forests, drowned eventually by the sea or buried by the earth, became coal. The coal that powered the Industrial Revolution. The coal that still heats homes and drives power stations in some parts of the world today. Every lump of it, a compressed memory of a forest that grew when the continents were different, in a world none of us would recognize. Time kept moving. The continents kept drifting. And roughly 335 million years ago, something extraordinary happened. All of the world's landmass came together one more time. Pangea, from the ancient Greek meaning all Earth, and that is exactly what it was. Every continent on Earth, every fragment and craton and piece of ancient crust gathered into one single landmass, stretching from pole to pole, surrounded on all sides by a single global ocean called Panthalassa. If you could have hovered above the Earth then, looking down, you would have seen something almost absurd. The familiar shapes of the modern world, but jammed together. North America pressed against Europe, South America tucked against Africa like two puzzle pieces finally found. India, not yet a peninsula, resting against Antarctica and Australia. The Mediterranean Sea, non-existent. The Atlantic Ocean, not yet born. It is in Pangaea that the puzzle piece argument for continental drift was first felt. Even centuries ago, European mapmakers noticed that the coastline of South America seemed to fit against the coastline of Africa, the bulge of Brazil into the indentation of the Gulf of Guinea. It was too perfect to be coincidence. And it wasn't. Those coastlines were once the same coastline, the same beaches, the same cliffs, the same river mouths, torn apart by the slow violence of the Earth over 130 million years of separation. Life on Pangaea was remarkable. Because the land was all connected, animals could walk, in theory, from one end of the Earth to the other without ever crossing an ocean. Dinosaurs were just beginning to appear. The first mammals, small and nocturnal, crept through the underbrush. Great reptiles dominated the land in a way they had never done before. But the interior of Pangaea was harsh. Vast and distant from the sea, the central regions of this supercontinent were probably among the most extreme deserts the Earth has ever seen. Summer monsoons sweeping in from Panthalassa may have brought seasonal rains to the edges, but deep in the heart of the landmass, the distances were too great for moisture to reach. The seasons would have been violent. Hot beyond imagination in summer, bitterly cold in winter, the kind of extremes that come when you are 1,000 miles from the moderating influence of the sea. Yet life endured, as it always does. Then, roughly 201 million years ago, Pangaea began to tear itself apart. The signs came first in the rock. Vast outpourings of lava erupted along what is now the eastern seaboard of North America and the western coast of Africa. These were the death throes of a supercontinent, the heat rising from below, pressing against the underside of the crust, finding weakness and exploiting it. The Triassic-Jurassic boundary. One of the great extinction events of Earth's history, the splitting of Pangaea released enormous amounts of volcanic gas into the atmosphere, warming the climate, acidifying the oceans. Perhaps half of all species on Earth vanished, and in their absence, the dinosaurs rose. The breaking of the world was also the making of the age of dinosaurs. The rift that split Pangaea apart did not open in one clean line. It fractured in stages. First, the northern landmass, what we call Laurasia, separated from the southern landmass of Gondwana. A narrow seaway opened between them, shallow at first, like a crack in a sidewalk that gradually fills with rainwater. That crack became the Tethys Sea, a warm, shallow tropical ocean that stretched across the middle of the world for tens of millions of years. The Tethys was rich in life. Its shallow shelves and warm temperatures made it a nursery for enormous diversity. The limestone that built the great cathedrals of Europe, the white chalk cliffs of Dover, the limestone plateau of the Sahara, all of these were once the floor of the Tethys Sea, built grain by grain from the shells of countless trillions of tiny sea creatures that lived and died in that ancient ocean. Then, the Atlantic began to form. It started in the north. A rift opened between what is now North America and Europe, narrow at first, a few miles wide, then tens of miles, then hundreds. At the center of this rift, molten rock welled up from the mantle, creating dew seafloor, pushing the continents apart, an inch or two per year, year after year, for 180 million years. The Atlantic Ocean is, in this sense, the youngest of the great oceans, still growing, still widening. Right now, at this very moment, as you lie still and breathe slowly, the Atlantic is about 2 centimeters wider than it was a year ago. As the northern Atlantic opened, the southern Atlantic followed. Africa and South America, those two great puzzle pieces, began their long separation. The split began roughly 130 million years ago in what is now the South. and crept northward over millions of years. The river systems of both continents still carry the memory of this. The Congo and the Amazon, so far apart today, were once tributaries of the same drainage system. The fish in their waters share ancient ancestors. The plants in their rainforests carry the same deep roots in a soil that was once the same soil. As the Atlantic widened, the ocean changed the climate of the world. New ocean currents formed, carrying warm water north from the tropics and cold water south from the poles. The Gulf Stream, which today makes Europe far warmer than it should be at its latitude, was born from the opening of the Atlantic. Without it, Britain and Norway would have climates more like Siberia. The shape of the ocean is not just a geographical fact. It is a climate system. It is the reason some places are habitable and others are not. The position of a coastline determines how rain falls, where deserts form, which valleys flood in spring. Every map of the world is also quietly a map of the weather. While the Atlantic was opening, the rest of the world was colliding. The breaking of Pangaea did not simply spread the continents evenly apart into the positions they now hold. It sent them spinning and drifting on unpredictable paths across the face of the planet. And wherever two of them met, the results were violent in the slowest possible way. The most dramatic of these collisions was still far in the future when Gondwana began to break apart. But it is worth pausing here to understand how mountains are made. Because mountains are not just scenery, they are the geological record of collision. They are the proof, written in stone, that the map of the world is always changing. When two continents collide, neither one simply stops. They are driven by forces too vast to halt. The crust crumples. Rock that was once at sea level is pushed upward. Kilometers of it, folded and thrust like a crumpled tablecloth, pushed from two sides. That is a mountain range. A slow-motion car crash between two pieces of a broken planet. The Appalachian Mountains of eastern North America are, by this logic, ancient. They were once as tall as the Himalayas. Born from the collision that helped build Pangaea, they have spent the last 300 million years wearing down. Rain and ice and wind, stripping away their peaks grain by grain, until what was once a wall of rock higher than Everest is now the gentle, rounded ridgelines of Virginia and Tennessee. The Urals in Russia tell a similar story, formed when Europe and Asia collided long before those were names we used, so old and so worn that they barely interrupt the great flat plains on either side. Yet once they stood enormous, a continental suture, the seam where two worlds became one. But the greatest mountain-building event in the relatively recent history of the planet began roughly 50 million years ago, when a piece of crust that had been drifting north for over 100 million years finally arrived at the underbelly of Asia, India. India is one of the most extraordinary travelers in the history of plate tectonics. When Gondwana broke apart, India detached from Antarctica and Africa and began moving north, not slowly like most continents, but fast, by geological standards, almost racing, as much as 20 centimeters per year at its peak. An astonishing speed for something the size of a continent. For 100 million years, India crossed what had been the Tethys Sea, pushing north and north and north, the ocean floor diving beneath it as it moved. Sea creatures that had lived in the Tethys found themselves trapped in the narrowing gap between two continents. The ocean was being swallowed. And then, approximately 50 million years ago, the two continents touched. India crashed into Asia with a force that had been building for 100 million years. The crust buckled, rock was pushed skyward. And from that collision, still ongoing today, came the Himalayas, the highest mountains on Earth. Mount Everest, Kangchenjunga, Lhotse. Every peak in that extraordinary range is the direct result of India's long journey north. And at the summit of Everest, nearly 9 kilometers above sea level, you can find marine limestone, rock formed from ancient sea creatures that lived in the Tethys Ocean before India began its journey, pushed up by the collision. lifted from the ocean floor to the highest point on the planet's surface, the sea at the top of the world. There is something deeply quieting about that. The highest place you can stand on Earth was once beneath the ocean, and the ocean that covered it no longer exists. Time does not just change things, it reverses them, it inverts them. What is up was down, what is land was sea, what is desert was swamp. The planet is always in the middle of becoming something else. While India was racing north, the rest of Gondwana was slowly dismantling itself. Africa, which had been at the core of Gondwana, found itself stranded near the center of the world as its neighbors drifted away. South America peeled off to the west. Antarctica and Australia moved south and east. India headed north, and Africa was left, the great anchor of the old world, roughly where it had always been. Africa is, in many ways, the most stable of the modern continents. Its ancient cratons go back billions of years. Some of the oldest rocks on the surface of the Earth are found in southern Africa. The continent has not drifted wildly. It has not crashed into anything dramatic in recent geological history. It has simply been there, present, persistent, ancient. But Africa has its own secret, a rupture forming beneath its surface, the East African Rift Valley, a tier in the continental crust that runs for thousands of kilometers from the Afar Triangle in the north, down through Ethiopia, Kenya, Tanzania, and into Mozambique. It is one of the most geologically active places on Earth, a place where the continent is, right now, in the early stages of breaking apart. In tens of millions of years, if the process continues, a new ocean will form in the space where the Rift Valley now stands. The Horn of Africa and the strip of land east of the rift may one day be an island continent, drifting slowly away from the main body of Africa into the Indian Ocean. The Rift Valley is why Africa has its Great Lakes, Tanganyika, Malawi, Turkana. These extraordinary bodies of water fill the low ground created by the spreading of the crust. They are among the deepest lakes in the world. Lake Tanganyika is nearly 2 kilometers deep, and the life within it, cut off from other water systems for millions of years, has evolved in extraordinary ways. The cichlid fish of the African Rift Lakes have diversified into hundreds of species in the geological equivalent of a heartbeat. The rift is not just splitting a continent, it is creating a laboratory for evolution. The Rift Valley also matters for the story of who we are. It is the cradle of humanity. The earliest evidence of our ancestors, Australopithecus, Homo habilis, Homo erectus, comes from the edges of this great tier in Africa. The opening of the rift changed the landscape of East Africa, pushing the rainforest back, creating open grassland. And it may have been those open grasslands that shift from forest to plain that encouraged our ancestors to stand upright and walk. A continent tearing apart changed the posture of a species. That is how deeply connected the shape of the Earth is to the shape of life. Of all the continents, Australia has the most isolated story. When Gondwana began to fall apart, Australia and Antarctica were still joined. They sat together at the bottom of the world, cold and forested, connected by a bridge of land that allowed life to move freely between them. The same animals walked through both. The same trees grew on either side. Then, roughly 45 million years ago, Australia began to drift north, slowly separating from Antarctica, opening a passage between them that would eventually become the Southern Ocean. That opening was itself a dramatic event. When the gap between Australia and Antarctica grew wide enough, the ocean could circulate freely around Antarctica. A new current formed, the Antarctic Circumpolar Current, the strongest ocean current on Earth. It isolated Antarctica thermally, cutting it off from the warm waters of the north. Antarctica began to freeze. The ice sheets built up, and a new era of glaciation began, one that continues today. Australia, meanwhile, drifted toward the tropics, and as it moved north, it carried with it an extraordinary cargo of life that had been evolving in isolation for tens of millions of years. Because Australia separated from the rest of the world before placental mammals had arrived in large numbers, The marsupials that had been there since Gondwana had the continent to themselves, with no competition from the more advanced placental mammals that were spreading across Asia, Europe, and the Americas. Australia's marsupials diversified wildly: kangaroos and wallabies, koalas and wombats, Tasmanian devils, and, until about 46,000 years ago, creatures even more extraordinary: the diprotodon, a wombat the size of a rhinoceros; procoptodon, a giant kangaroo that stood 3 meters tall; megalania, a monitor lizard 7 meters long. Australia's isolation made it a world apart, a separate experiment in evolution, a continent that asked the question, what happens to life when it has a whole continent to itself and no one else to compete with? The answer is beautiful and strange in equal measure. Even the plants of Australia tell the story of isolation. The eucalyptus, which dominates so much of the continent, is found almost nowhere else in its natural form. It evolved in the drying conditions that came as Australia moved north. Its oils a defense against the insects and the heat of a land that was learning to be dry. The whole continent is a message in a bottle from the deep past, sealed up and set adrift before the modern world was finished being made. North America and South America share a name and a hemisphere, but for most of geological history, they were strangers. When Pangaea broke apart, North America drifted west and slightly north. South America, for a time, was an island continent, surrounded on all sides by ocean, isolated, like Australia but in the tropics. South America's isolation lasted for roughly 30 to 40 million years, long enough for its wildlife to evolve in extraordinary directions. The giant ground sloths, the glyptodonts, armored animals the size of compact cars, terror birds, flightless predatory birds 2 meters tall that ruled the open plains, and the ancestors of modern horses, camels, and llamas, evolving on a continent completely cut off from the rest of the world. Then, about 3 million years ago, something happened that rewrote the wildlife of 2 continents. The Isthmus of Panama rose. As the Caribbean tectonic plate shifted, a land bridge gradually formed between North and South America. First just shallow water, then islands, then a continuous strip of land, and through that corridor, the animals of 2 isolated worlds met for the first time. Scientists call it the Great American Biotic Interchange, and it was one of the most dramatic ecological events in the last few million years. Mastodons and horses from the north moved south into South America. Ground sloths and glyptodonts from the south moved north into North America. Predators that had never met each other before suddenly shared a continent. Ecosystems that had evolved separately for tens of millions of years were suddenly thrown together. Many of the South American endemic sink species could not compete with the more recently evolved creatures from the north. They vanished. Some persist today: the opossum, the armadillo, ancient survivors of that ancient world. But the great diversity of isolated South American life, the terror birds, and the giant sloth, did not outlast the interchange. The closing of Panama also did something to the oceans. By separating the Pacific from the Caribbean, it redirected the flow of warm tropical water and helped strengthen the Atlantic circulation. That change in ocean circulation contributed to the cooling of the climate that eventually led to the ice ages. A strip of land 3 million years ago connected 2 continents, reshuffled the world's wildlife, changed the ocean currents, and helped trigger the ice ages that would shape human evolution. Everything is connected. The shape of the land determines the flow of the sea. The flow of the sea shapes the climate shapes the life, and life, in the end, shapes the shape of the land. The Mediterranean Sea is one of the most storied bodies of water on Earth, the cradle of so much that we call civilization: Rome, Greece, Egypt, Carthage. The cultures that built the foundations of the modern world all grew up around its shores, and yet, in the deep history of the planet, the Mediterranean is a youngster, and it has a secret. About 6 million years ago, the Mediterranean Sea dried up, not partially, completely. It is called the Messinian salinity crisis. As Africa drifted north toward Europe, the narrow connection between the Mediterranean and the Atlantic Ocean gradually closed. The Strait of Gibraltar pinched off by the collision of continents. Without fresh Atlantic water flowing in, and with the heat of the North African sun beating down, the Mediterranean began to evaporate. For about 600,000 years, the Mediterranean sat mostly dry, a vast, searing salt flat, 3 to 5 kilometers below sea level in some of its deeper basins, surrounded by towering cliffs that were once ocean shore. The sun would have hammered down onto an expanse of white salt that stretched further than the eye could see. The rivers of Europe and Africa kept flowing into this emptied basin. The Nile, draining from the African highlands, would have carved a canyon far deeper than the Grand Canyon as it wound down to the evaporated seafloor. Geologists have found evidence of this canyon beneath the modern river delta in Egypt, ancient rock cut by a river in a world we cannot imagine. And then, roughly 5.3 million years ago, the Atlantic broke through. The rocks at Gibraltar gave way. A trickle became a stream became a torrent, and then, in what geologists estimate may have been the greatest waterfall in the history of the planet, the Atlantic poured into the Mediterranean basin, the Zanclean flood. Estimates suggest the Mediterranean may have refilled in a matter of months to a few thousand years, a vast basin, kilometers below sea level, flooding with the full weight of the Atlantic behind it. The sound of that water would have been beyond anything any living creature had ever heard. The thunder of an ocean pouring into an empty world, and the creatures that had lived in the dry basin, whatever hardy species had adapted to that strange, low, salty world, would have had no warning as the walls of water came. The Mediterranean that exists today, that blue, warm, history-soaked sea, is the sea that rose from that flood. Every ship that ever crossed it, every civilization that ever built a port on its shore, was resting on the legacy of a catastrophe 5 million years old. By now, if you have been following this slow journey, you have traveled from the molten birth of the planet through Snowball Earth, through Gondwana and Pangaea, through the opening of the Atlantic and the rise of the Himalayas and the drying of the Mediterranean. The world is beginning to look familiar, but it is still not quite the world we know. There are details to fill in, coastlines to refine, seas to drain, mountains to continue rising, and other mountains to wear down. The planet is always in the middle of something. 5 million years ago, the world looked recognizably modern. The continents were roughly where they are today. The oceans had their familiar shapes. But the climate was warmer. Sea levels were higher. There were no permanent ice sheets in Greenland. The Arctic was forested rather than frozen, and from a certain angle, this world might have looked like a warmer, wilder version of the present. Then the cooling began, driven partly by the closing of Panama, partly by the continued rise of the Himalayas, pulling carbon dioxide from the air. The climate gradually shifted. Ice formed at the poles. The great ice ages began. And in that cold, reshaped world, our own story truly began. But the shaping of the world was not only a matter of geology, it was a matter of discovery. Because for all of human history, the shape of the world was a mystery. People lived on pieces of the map without knowing the whole. The world was real beneath their feet, but the map of it existed only in fragments, incomplete, distorted, uncertain. That is the other story of the world map, not just how the continents were made, but how we discovered them. For as long as humans have existed, they have tried to make sense of the land around them. The earliest maps were not drawn on paper. They were scratched into clay, drawn with charcoal on stone, or simply held in the memory, passed from person to person in the form of stories and landmarks. Where does this river go? How far is it to the next valley? What lies beyond that mountain range? These are not questions of curiosity alone. They are questions of survival. Knowing the land, understanding its shapes and its limits, is one of the most fundamental things a human being can do. The earliest maps we have found are thousands of years old. A clay tablet from ancient Babylon, roughly 2,500 years old, shows the world as a flat disk surrounded by a ring of water. Babylon sits at the center. Of course it does. People have always placed themselves at the center of the world. It is one of the most human of habits. The ancient Greeks pushed further. Anaximander, in the 6th century BC, drew a map that showed the world as a cylinder rather than a flat disk. He was wrong about the shape, but he was beginning to ask the right questions. How big is the world? What is its shape, and where do its edges lie? It was Eratosthenes, the librarian of Alexandria in the 3rd century BC, who first calculated the circumference of the earth with remarkable accuracy. He noticed that on the same day, at the summer solstice, a stick in Syene cast no shadow, while a stick in Alexandria to the north cast a shadow at an angle of about 7 degrees. From that difference and the known distance between the two cities, he calculated the Earth's circumference. He was within a few % of the correct answer. 2,000 years before satellites. 2,000 years before anyone had seen the Earth from above. Just a stick, a shadow, and the extraordinary power of human reasoning. But knowing the Earth was round and knowing its shape were different things. The Greeks had the Mediterranean. They had glimpses of Africa and Persia and India. But beyond those horizons, the world fell into uncertainty. Some maps showed imagined continents to balance the known land masses. Others left great blank spaces labeled simply with words that meant, "Here there be nothing we know." For centuries, the map of the world was assembled, piece by piece, through the slow accumulation of travelers' accounts. The Silk Roads, those great trade routes that linked China to the Mediterranean, were not just highways for silk and spice. They were highways for knowledge. Merchants who traveled their length brought back not only goods, but descriptions of lands, reports of mountains and rivers and seas that no one in the West had ever seen. The Arab geographers of the medieval period were among the finest cartographers the world has known. Al-Idrisi, working in 12th century Sicily for the Norman king Roger II, drew a world map of extraordinary detail. It covered the known world from China to the Atlantic, from Scandinavia to sub-Saharan Africa. He had drawn it south side up, which is why when you first look at it, it seems disorienting. But turn it around, and you see a world that is recognizable. Incomplete, yes, missing the Americas, Australia, and much of Asia, but real, assembled from hundreds of accounts, measurements, and descriptions collected over years. In China, cartographers had been mapping their own vast world since long before Europe. The Chinese maps of the Tang dynasty showed extraordinary knowledge of Central Asia. The great Zheng He expeditions of the early 15th century sent fleets of enormous ships throughout the Indian Ocean, reaching the Persian Gulf, the Red Sea, and the east coast of Africa. The Chinese knew a great deal of the world. They simply did not press further east or west into the unknown oceans. The Polynesian navigators deserve their own chapter in the story of human exploration, without compasses, without charts, navigating by stars and swells and the flight of birds. They colonized the entire Pacific Ocean, from Hawaii to New Zealand, from Easter Island to the Philippines. They carried in their minds a map of the largest ocean on Earth, encoded in song and story and the feel of the wind on skin. Their maps were not drawn, they were lived. And yet, for all of this, the Americas remained unknown to the people of Europe, Asia, and Africa, two enormous continents, home to tens of millions of people, civilizations of extraordinary complexity, completely absent from the maps of the rest of the world, a mystery the size of half the globe. The 15th century changed the map forever, not because of a single voyage, though some voyages stand out clearly, but because of a shift in attitude, a growing belief that the ocean was not a barrier, but a road, that the horizon was not an edge, but an invitation. The Portuguese led the way, Prince Henry the Navigator, funding voyage after voyage down the coast of Africa, each one pushing a little further south then the last, learning the winds, learning the currents, building the knowledge, bit by bit, that would eventually allow Bartolomeo Diaz to round the Cape of Good Hope in 1488. For the first time in history, a European ship had found the way around Africa. The Indian Ocean was not a closed sea. It was open, connected, part of a world that went all the way around. Then Vasco da Gama followed in 1498, making it all the way to India. The sea route that the Portuguese had been building for decades finally reached its destination. The spice trade, which had flowed overland for centuries, could now flow by sea. The economy of the world would shift. The centers of power would shift with it. And then, in 1492, Christopher Columbus sailed west. Columbus was not looking for a new world. He was looking for Asia. He believed, wrongly, that the ocean between Europe and Asia was narrow enough to cross. He was lucky in a historical sense that something was there, because if the Americas had not existed, his ships would have run out of food and water somewhere in the middle of the Pacific. What he found was not Asia. It was a world the maps had no room for, a continent or two stretching from near the Arctic to near the Antarctic, teeming with life, inhabited by people who had been there for 20,000 years, and completely unknown to the rest of the world. The geographer Martin Waldseemüller drew a new map in 1507. He was the first to put the name America on a map, honoring Amerigo Vespucci, who had recognized that this land was a new continent, not Asia, not a known land, something entirely new, a fourth part of the world. That map, now kept in the Library of Congress, is sometimes called the birth certificate of America. The moment a continent gained a name, the moment the map began to take the shape we would one day recognize. Magellan's circumnavigation, begun in 1519, completed the picture in another way. His fleet set out from Spain, crossed the Atlantic, found the passage around the tip of South America that now bears his name, crossed the Pacific, reached the Philippines, and eventually returned to Spain. Though Magellan himself did not survive the voyage, 18 of his crew did, and what they proved was something that Eratosthenes had calculated 2,000 years before. The Earth was round, and you could sail all the way around it. The world map was not complete even then. Australia was not yet known to Europeans. The Arctic and Antarctic were mysteries. The interiors of Africa and Asia and the Americas were largely unknown. But the outlines were there, the shape of the thing, the rough sketch of the world as we know it. The voyages of exploration gave us the map, but for a long time, no one understood why the map looked the way it did. The shapes of the continents were known. The fact that South America and Africa fit together had been noticed since the first accurate maps were drawn, but the explanation for it was missing. In 1912, a German meteorologist named Alfred Wegener published a theory. The continents, he argued, had once been joined together. They had drifted apart. He called it continental drift. The scientific establishment rejected him almost entirely. The main objection was simple and devastating. He couldn't explain the mechanism. What force could possibly move a continent? The idea seemed absurd. Rocks don't move. Not like that. Wegener died in 1930, crossing the Greenland ice sheet on an expedition. He never saw his theory accepted. The vindication came after his death. In the 1950s and 1960s, oceanographers began mapping the ocean floor. What they found astonished them. Running down the middle of the Atlantic, and indeed down the middle of every ocean, was a mountain range, a continuous ridge of volcanic rock rising from the ocean floor, and spreading outward from that ridge on both sides was new seafloor, rock created at the center and pushed away to either side. The mid-Atlantic ridge, a seam in the ocean where the earth was pulling apart, where new rock was being made, where the Atlantic was growing wider year by year. This was the mechanism Wegener had been missing. The seafloor spreads. The ocean floor is being created at the ridges and consumed at the trenches. where one plate dives beneath another. The continents are passengers on these plates. They don't move through the ocean like ships. They're carried on the ocean floor as it moves. The theory of plate tectonics was born in those years, and with it, everything in geology was reframed. Every mountain range explained. Every earthquake understood. Every volcanic arc made sense. The surface of the Earth was not fixed. It was a mosaic of moving plates. A slow, grinding machine the crust of the planet onto timescales of millions of years. Wegener had been right. His mechanism had been wrong. But his instinct, born from looking at a map and noticing that the pieces fit, had been correct all along. Plate tectonics did more than explain the past. It helped us read the map in a new way. Suddenly, the distribution of earthquakes made sense. They cluster along the edges of plates. The ring of fire around the Pacific is not a coincidence. It marks the boundary where the Pacific plate is diving beneath the surrounding continents. Every earthquake in Japan, in Indonesia, in the west coast of the Americas, is an expression of that same process. The volcanoes of Iceland rise above the mid-Atlantic ridge. Iceland is, in fact, a piece of the ocean ridge that has grown tall enough to rise above the sea surface. It sits astride two tectonic plates that are spreading apart. You can walk in Iceland from the North American plate to the Eurasian plate in a matter of minutes. Stand with 1 foot in each. Feel the continent beneath you slowly pulling away. The Himalayas rise because India is still pushing north into Asia. The collision hasn't stopped. Everest is slightly taller this year than it was last year. The mountains are still growing, even as erosion strips them back. The balance between uplift and erosion determines their final height. For now, uplift is winning. The San Andreas Fault in California is a transform boundary, where two plates are sliding past each other rather than colliding or spreading. Los Angeles sits on the Pacific plate. San Francisco sits on the North American plate. They are moving toward each other at about 5 centimeters per year. In roughly 15 million years, Los Angeles will be where San Francisco is. The map, as always, is temporary. If the past is any guide, the world map is not finished. The continents are still moving. The plates are still in motion. And geologists, applying the same principles that let them read the past, have made predictions about the future. In about 50 million years, Africa will have moved far enough north to close the Mediterranean completely. The sea that cradled civilization will become a range of mountains as Africa collides fully with Europe. Something like the Himalayas will rise where the sea now lies. Australia, continuing its northward drift, will push into Southeast Asia. The islands of the Indonesian archipelago will be crumpled and folded as the two plates meet. The Atlantic will continue to widen, but the Pacific will continue to shrink, consumed at its edges by subduction. Eventually, in a few 100 million years, the Pacific may close entirely. The Americas and Asia will collide, and from that collision, another supercontinent may form. Some geologists call it Pangaea Proxima, others call it Amasia. The name doesn't matter. What matters is the pattern. The plates gather, they break, they gather again. The cycle that has been running since the very beginning of the planet is still running. It has not stopped. It will not stop. Not in any time frame we can meaningfully imagine. The map we carry in our heads, the one that seems so permanent and true, is of a moment, one frame in a 4 billion year film, the frame we happen to live in. There is a place in Greenland where rocks have been found that are 3.8 billion years old, some of the oldest surface rocks on Earth. Hold that thought for a moment. 3.8 billion years. If the entire history of the Earth were compressed into a single year, these rocks formed in early February. Humans appeared on December 31st, in the last few minutes before midnight. And yet those rocks are still here, still on the surface, still accessible, still telling their story to anyone who knows how to read it. Geologists can read rock the way a librarian reads a book. The minerals, the crystals, the way they are arranged, the elements locked inside them, all of these carry information. The temperature at which the rock formed, the pressure it was under, the direction it moved, the age of the crystals within it. Every rock is a record. Every outcrop is a library. The earth has not forgotten a single thing that has happened to it. It has just stored the memories in stone. In the mountains of Scotland, there are rocks that were once part of the same mountain chain as rocks now found in Norway, Greenland, and the Appalachians of North America. The mountains that formed when Pangaea was assembled were torn apart when Pangaea broke, their fragments carried to different sides of the Atlantic. But the rocks remember the connection, the same fossils, the same minerals, the same structures on both sides of an ocean that didn't exist when those mountains were made. In Central Africa, there is a region called the Congo Craton, rock that has been stable for roughly 2.5 billion years, unchanged in all that time. While continents formed and broke and collided around it, this ancient piece of crust sat steady, patient, as old as anything on the surface of the earth. And somewhere in Australia, in a remote region of Western Australia called the Jack Hills, there are tiny crystals of zircon that are 4.4 billion years old, almost as old as the Earth itself, the oldest material ever found on this planet. 4.4 billion years. The Earth formed 4.5 billion years ago. These crystals formed 100 million years later, when the planet was still cooling, before the oceans fully formed, before life existed, before the first continents stabilized. And there they are, in the desert of Western Australia, sitting in the rock, waiting, older than almost anything in the solar system that we can hold in our hands. We have spoken much of land, but 2/3 of the Earth's surface is ocean, and the ocean floor has its own extraordinary history. The oldest ocean floor on Earth is roughly 180 million years old. The youngest is being made right now, at the mid-ocean ridges, where molten rock wells up from the mantle and hardens into new seafloor. The ocean floor is young because it is constantly being recycled. At the subduction zones, where plates dive beneath one another, the old seafloor is dragged back down into the mantle, melted, and eventually returned to the surface through volcanoes. The ocean floor is a conveyor belt, created at one end, destroyed at the other, an endless cycle with no beginning and no end. The continents, because they are made of lighter rock, resist being pulled down. They accumulate on the surface, growing over time through volcanic additions and the crust scraped off subducting plates. That is why the oldest rocks on Earth are found on the continents, not on the ocean floor. The continents are the museum. The ocean is the factory. The deep ocean trenches are among the least explored places on Earth. The Mariana Trench in the Pacific reaches nearly 11 kilometers below sea level. If you dropped Everest into it, the peak would still be more than 2 kilometers underwater. The pressure at the bottom is over 1,000 times the pressure at the surface. More people have walked on the moon than have reached the deepest point of the ocean, and yet even there, life has found a way. Creatures that live in total darkness, under crushing pressure, at temperatures near freezing, where the only energy comes from the chemistry of the rock rather than the light of the sun. These deep-sea creatures may be the closest living relatives of the very first life on Earth, survivors from a time before photosynthesis, before the sun was a usable source of energy, before the world as we know it existed. The ocean is not just the present, it is a window to the beginning. Part 20. The Map and the Mirror. We have come a long way tonight, from the molten, bombarded surface of the newborn Earth, through the first frozen world, through the gathering of Rodinia, through the swamps of Gondwana, through the assembly of Pangaea and its long, slow dissolution, through the opening of oceans, the building of mountains, the drying of seas, the connecting of continents, through the Babylonian mapmakers placing themselves at the center of their disk, through the Greek geometers calculating the size of a world they couldn't see, through the Arab cartographers stitching together a world from travelers' tales, through the Portuguese navigators edging further and further south, through Columbus lost in his certainty, finding something he couldn't name, through Magellan's crew returning to a Spain they had left 3 years before, carrying proof that the world went all the way around, and through Wegener staring at a map in 1912, noticing that the puzzle pieces fit, and asking why. The map is not just a picture, it is a story. And like all good stories, it is still being told. Right now, the Atlantic widens. The Himalayas rise. East Africa tears itself apart, slowly. Australia moves north. The Pacific shrinks. The plates grind and slide and push. The Earth continues its patient, restless work. The map we look at in school, pinned to the wall, its borders drawn with such confidence, is a moment in time, as brief in the history of the planet as a single frame of film in the longest movie ever made. There is something deeply calming about that. Our borders, our conflicts, our certainties about where one thing ends and another begins are temporary arrangements. The land beneath them has been many things before, and will be many things again. You are lying right now on a piece of crust that was once part of something else, that will one day be part of something else again. The ground beneath your house has been ocean floor, has been mountaintop, has been equatorial jungle, has been buried under ice, has been baked under a desert sun, and before all of that, it was molten rock, cooling in the dark of a young planet. Everything is always becoming something else, and perhaps that is a comfort. The earth is not rigid, it bends, it breaks. Again and again and on a schedule too slow for any of us to see, but real nonetheless. Part 21. The Quiet of Deep Time. There is a concept that geologists love and that everyone else finds difficult. Deep time. Not time as we experience it, not days and seasons and years, not even centuries and millennia, but millions of years, hundreds of millions, billions. The geologist John McPhee once described deep time this way: extend your arms out wide, fingertip to fingertip. That distance represents the whole history of the Earth. The Precambrian, when the continents were forming, takes up everything from your left fingertip to somewhere past your right elbow. The Cambrian explosion, when complex life appeared, is just past your right wrist. The dinosaurs, the great reptiles we love to imagine, occupy the last joint of your right middle finger, and all of human history. Everything from the first stone tools to this moment could be erased with a single stroke of a nail file across the tip of your right middle finger. That is deep time. That is the scale in which the map was made. It is humbling, and it is also strangely peaceful. When you hold the scale of deep time in your mind, the anxieties of a human life become very small, not because they don't matter. They do. They matter entirely, but they take their place in a larger story, a story in which even mountains are temporary, in which even oceans come and go, in which the very rock beneath your feet has been somewhere else and will go somewhere else again. You are here now, in this particular moment, on this particular piece of the world, which is, for now, roughly where it is, and that is enough. The history of the continents is also the history of who we are. Every migration our ancestors made was shaped by the map. The route out of Africa, across the Sinai and into Eurasia, was possible because sea levels were low enough to leave coastal routes accessible. The crossing into the Americas was made possible by Beringia, that vast tundra land bridge that existed only because so much water was locked in ice. The peopling of the Pacific required thousands of years of navigation across the largest ocean in the world. Every people in every place arrived there through a journey that was shaped by the land available to them. The continents determined where we could go. The mountains and rivers determined where we settled. The isolation of island continents shaped our languages and our myths. The connections between continents spread our crops, our animals, our diseases, and our ideas. The reason wheat was the foundation of civilization in the Middle East is partly because the Fertile Crescent had the right wild grasses, the right climate, and the right geography for surplus agriculture. The reason the Americas were so isolated technologically for so long is partly because the orientation of the Americas, running north to south rather than east to west, made the spread of crops and animals across different climate zones much more difficult. The map was not neutral. Its shape had consequences for who grew powerful, for who stayed isolated, for who met whom and when, for the diseases that spread, and the crops that could grow, and the empires that could be built. We did not make the map, but the map made us. If you look at a map of the world tonight, really look at it. Let your eyes trace the coastlines, follow the mountain ranges, notice where the rivers run, and why. You are reading something ancient, that long finger of land pointing down from Southeast Asia, the Malay Peninsula. That is the collision zone between two plates, buckled by pressure from below. The curve of the Caribbean islands traces the arc of a subduction zone. The flatness of the Amazon basin was once the floor of a shallow sea, and the foreland of a mountain range that no longer exists. The Great Plains of North America are built on sediment eroded from the Rockies, ground down, and spread east by ancient rivers. The Sahara Desert was once a lush savanna. The Mediterranean seafloor holds salt deposits kilometers thick, the memory of when it dried. The English Channel was once dry land. Britain was not always an island. The Persian Gulf was a river valley at the height of the last ice age, and some researchers believe the garden-like landscapes described in ancient myth may be a memory of the fertile valleys that existed there before the sea rose and covered them. Every culture that has ever existed has myths about floods, waters rising, worlds ending, land disappearing. Perhaps those myths are not metaphors. Perhaps they are memories. Thousands of years of oral tradition preserving in story form the actual experience of living through the end of the Ice Age, when sea levels rose by 100 meters, when coastlines retreated inland by hundreds of miles, when familiar landmarks vanished beneath the waves, when the world, quite literally, changed shape within living memory. The map carries those memories, even when we don't know to look for them. Part 24. Iceland, where you can watch it happen. There is one place on Earth where you can see the making of the world happening in real time, not in a laboratory or on a screen, but standing on the ground. Iceland sits on the mid-Atlantic ridge, the ridge that runs down the center of the Atlantic Ocean and is slowly pushing the continents apart. In Iceland, that ridge rises above the sea surface, made taller by a hot spot of volcanic activity beneath it. And because of this, Iceland is one of the most geologically active places on Earth. Volcanoes erupt every few years. Geysers shoot boiling water into the air. Lava flows across the landscape. The land is being created right now from the rock welling up from the mantle below. In southwest Iceland, there is a valley called Thingvellir. It is a rift valley, a low place between two cliffs, where the North American plate and the Eurasian plate are pulling apart. The valley floor is sinking, millimeter by millimeter, as the two sides drift away from each other. The cliffs on either side get a little further apart each year. If you stand in that valley, looking up at those cliffs, you are standing in the widening seam of a growing ocean. The Atlantic, in its infancy, must have looked something like Thingvellir, a rift, a crack, a place where the world was opening, and the ocean began. There is nowhere else on Earth where you can stand at the very edge of two separating continents and feel the earth pulling apart beneath your feet. It is quiet there. The wind moves through the valley. The water in the river is glacially clear, and the cliffs that face each other across the rift are moving apart at the pace of a growing fingernail. Invisible, unstoppable. Part 25. Coming home to a moving world by now, if you are still with us. The world outside your window is quiet. The night has deepened. The sounds of the day have faded, and somewhere beneath you, the rock is still, or seems to be. In truth, of course, it is moving. It is always moving. The plate beneath your home is carrying you, right now, at roughly the speed at which your fingernails grow, in a direction you probably can't point to. North, perhaps, if you are in Europe or North America. A little northwest, a fraction of a degree each year, towards something it will take millions of years to reach. The ground beneath you has been ocean, has been mountain, has been jungle, has been desert, has been glacier, and long before any of that, it was just rock crystallizing from magma in the silence of a cooling world. The map on your wall is a very recent invention. The world it describes is billions of years old, and the world it will describe in the future does not exist yet. It is being made, right now, in the slow grinding of plates, in the rising of mountain ranges, in the widening of oceans, in the rifts opening in East Africa, in the volcanoes building new land from the floor of the Pacific. The world is not finished. It never was. And perhaps that is what makes it so endlessly worth paying attention to. Wherever you are tonight, whatever piece of the ancient world you are resting on, you are part of this story. Not a spectator, part of it. The same atoms in your body have been in this story for billions of years. In the rock, in the ocean, in the air, in the ancient forests of Gondwana, in the shallow seas of the Tethys, in the bodies of creatures whose names have never been given, and whose world we can only imagine. You are, in the most literal sense, made of the history of the continents. The continents began in fire. They gathered and broke and gathered again. They carried life with them across 500 million years. They made room for the ocean and then stole it back. They built mountains and worn them down. They opened seas and closed them. They connected worlds that had been apart and separated things that were once together. And through all of it, life persisted, adapting, diversifying, finding ways to survive in every corner the continents offered, until one of those adaptations looked at a piece of clay and tried to draw the world on it, and another looked at a shadow and calculated the size of the planet, and another looked at a map and noticed that the coastlines fit, and another drilled into the ocean floor and found the proof of what they suspected. The story of the world map is the story of the world itself, made first in rock and heat, and then remade in the imagination of the creatures the rock eventually gave rise to. You carry that map in your mind. You always have. Even if you never thought of it this way, let it rest there now. That image of the world, all its blues and greens and browns, all its familiar shapes, and know them for what they are, not fixed, not permanent, but alive, still moving, still becoming. As everything always is, rest now. The earth is doing the rest. It has been doing it for 4 billion years, and it will carry on tonight just as it always has. Quietly, slowly, without any help from any of us. Good night, and thank you for walking across the whole history of the world with me tonight. The map goes on. It always does. And somewhere out there, far beneath the ground, in the slow, deep dark of the mantle, the next chapter is already being written.